All right, real short video for lesson 5, dealing with trapezoids and kites. We're going to focus on some characteristics of isosceles trapezoids in particular, and then some conversation about kites. There's some additional information about kites that I'm going to mention that is not listed in the PowerPoint here, but it's going to be part of our conversation as we do some work over the next couple class meetings and have our exam. And so I want to make sure that we wrap up this unit well. And so the key thing I want you to know is that you should be able to use and again apply these properties for trapezoids and kites. All right. So trapezoids and kites are different animals. In kites, there are no sides parallel. In trapezoids, there's one pair of sides parallel. In kites, there are two pairs of adjacent congruent sides. In trapezoids, unless the trapezoid is isosceles, there are no congruent sides. And if or there doesn't have to be any congruent sides. There could be two sides congruent in a trapezoid, but in an isosceles trapezoid, you would at least have two pairs of sides, or one pair of sides congruent, the non-parallel sides. One of the two parallel sides could be congruent to the two legs, but that's neither here nor there. So the first theorem that we have is that the base angles in an isosceles trapezoid are congruent to each other. The base angles in an isosceles trapezoid are congruent. So if we know that this is an isosceles trapezoid, again, one of the vocabulary explorations that we had in lesson 1 was recognizing that this and this are base angles, all right? But furthermore, these angles here are also base angles, all right? So this is a pair of base angles, and those will be congruent, just like if this were an isosceles triangle and we got the top of it cut off, all right? Then these base angles are congruent. But the way that this is cut, these angles, since they're parallel, these angles will also be congruent to each other, all right? And the reason is because these have to add up to 180, and these have to add up to 180. If these are congruent, and you subtract the same amount from 180, then you're left with the same amount here. All right, so that's why those are congruent. I'm not going to work that full proof, and I don't think that that's necessary, but in an isosceles trapezoid, the base angles are congruent. Not the consecutive angles, the base angles, all right? So these angles, the same side interior angles, are not congruent. They can't be, otherwise this would be a rectangle. And so these angles are not congruent, but these base angles, and base doesn't mean bottom. If this figure is drawn like so, then these angles would be congruent and those angles would be congruent. I hope that that makes sense as you think about how to apply isosceles trapezoids. Specifically, I wanted to draw that here, draw your attention here, so that you can see how you would approach these types of items, all right? And so you're given this isosceles trapezoid. The measure of angle 3 is going to equal this. This angle and this angle are congruent. So the measure of angle 3 is 111 degrees. Now, the measure of angle 1 and 2 are the same, but I can't say measure of angle 1 equals measure of angle 2, I'm done, I need to find its measure. And so we can either say that the measure of angle 1 plus 111 makes 180, or the measure of angle 2 plus 111 makes 180, doesn't matter. I'm going to use 1 because here these are same side interior angles, subtract 111 to find out that the measure of angle 1 equals 69. And the measure of angle 1 equals the measure of angle 2, so the measure of angle 2 is also equal to 69 by substitution. The diagonals of an isosceles trapezoid are congruent. The diagonals of an isosceles trapezoid are congruent. So if I have an isosceles trapezoid, meaning that we've got these sides parallel and these sides congruent, when I draw the diagonals in, those diagonals will be congruent. The way that we prove that is we basically have this, this triangle with our base angle at D, and then we have this part of the isosceles trapezoid, B, C, D. This is A, D, C. This is the reflexive side, DC. And this is the base angle at C and the base angle at D are congruent to each other. So that's this angle is that right there. This angle is that right there. Sorry that my drawing isn't quite. Oops, this says, let's try to draw that a little bit better. Hit it. There we go. This one a little bit better. Okay, and so these two triangles are congruent by side, base angle, by the definition of an isosceles triangle, and then the or I guess that was a couple slides ago. My bad. That was theorem 6 15. and then these, so these are congruent by the definition of isosceles triangle. These angles are congruent by theorem 6.15, and then these sides are congruent by the reflexive POC. Therefore, the diagonal AC and BD are congruent by CPCTC, or the definition of congruent triangles. I'm not going to write out that proof. I'm not going to have you write it out. We're just going to use that in some of our work. All right. So the way that we would apply that is in a situation like so. We are being told that TV is this expression, US is this expression. We know that the length, that those segments are congruent by theorem 6.16. TV is congruent to US, segment TV is congruent to segment US. Therefore, their lengths are equal by the definition of congruent. I get to substitute the expressions for the length of TV and the length of US. And then I can solve my equation doing my basic algebra 1. I'll subtract an x from both sides, I'll add a 1 to both sides, and QED, I got my answer here. I've got x is equal to 3. Okay? And so that's the kind of work that I would have you do in this section pertaining to isosceles trapezoids, saying that or recognizing that the diagonals are congruent, recognizing that the base angles are congruent, hopefully pretty basic stuff, and hopefully makes you feel comfortable. All right? When we jump onto kites, though, we're going to talk about how the diagonals in a kite are perpendicular. And so here is our picture of a kite. And if this is a kite, meaning that this, and this are congruent to each other, as these are congruent and those are congruent, then I can draw the diagonals in, and those diagonals will make right angles. They will make right angles. And the way that we approach that proof is not too shabby. One of the things that we're going to recognize is that there's a couple other things that happen here. We're going to recognize that this diagonal is cut in half, but the other diagonal is not cut in half. And so there's a lot of fun facts that we can explore and deal with here. Essentially, we've got ourselves a situation where we're going to find out that these angles are also bisected. And we can do that just using one of these diagonals to show that we have a pair of congruent triangles by, actually if I draw it like this, you can see it a little bit better. If I have this drawn, we've got congruent triangles by side, side, side. That means that this angle and this angle are congruent, this angle and that angle are congruent. And so it sets us up for some level of success in determining that we have congruent triangles here in this situation. I've got a pair of sides given, a pair of angles that we know are congruent from this situation, and then this side is reflexive. So I've got side, angle, side here, which means that these angles are congruent, but they're also supplementary, which means that they make right angles. All right? That one's a little bit of a tricky proof for us because it involves proving these triangles congruent and then going here, kind of like we did in lesson 4.7. And so I want to make sure that you see that you recognize that you are capable of doing that, but I'm not going to have you do that proof right now. You don't have to write that out, but you should be aware that the diagonals in a kite are perpendicular. So if that's the case here, what we want to recognize here is that angle 1 is going to be 90 degrees. And if this is 22 degrees, then this is also 22 degrees. This is going to be 90 degrees, and so these angles are going to be complementary. All right, they're going to add up to 90 degrees. And so we can recognize here that the measure of angle 1 is 90. We can recognize that the measure of angle 2 plus 90 plus 22 is 180. Subtract the 90, and we can show that these are complementary. That's kind of what I was saying moments ago. Subtract 22, and we get 68 for the measure of angle 2. So here we get to do a little bit of triangle angle sum theorem. We get to do a little bit of work with supplementary angles, complementary angles, be able to create and solve equations. There is zero expectation that you do this in your head. It is expected, there is an expectation that you write and you solve equations. All right? Here, the equation that you write gives you the answer. Here, the equation that you write, or this equation that you write, will get you to the answer, but you still have to do that work. All right? So hopefully this kind of shows you those key concepts and ideas and how angles are related, how diagonals are related as we discuss trapezoids, specifically isosceles trapezoids and kites.